I'm going to talk about an example of using dimensional analysis to figure out what a relationship has to be in physics just based on what units you're measuring things in. So this is a classic example, the period of a pendulum, so a mass on a string that's just swinging back and forth. We assume that the period of a pendulum could depend at most on the mass at the end of the string, length of the string, and what the local acceleration due to gravity is, so the value of little g. If that series of assumptions is true, then what is the equation for the period of a pendulum? This is a good example because simultaneously to show you how useful dimensional analysis is and also the limitations. So what we're saying is there has to be some relationship where I have a period measured in seconds proportional to, because there could be an overall constant of proportionality, mass of the pendulum, and mass we have to measure in kilograms. So we'll say that is to a power a. Local acceleration due to gravity, and that is an acceleration in meters per second squared raised to the power b, and it could depend upon the length of the pendulum, and that is a length in meters in our MKS system. So what we're saying is, on the left-hand side, I have to have seconds. On the right-hand side, I can make that out of kilograms. I have a meter, I have seconds squared, and I have a meter. The first thing to observe is this kilogram can't cancel out with anything else. So dimensional analysis immediately tells us that that constant A has to be 0. Meaning the period of a pendulum has to be independent of mass. We don't have a choice about that. Now, if I'm going to get a second, the only thing that involves time is the acceleration due to gravity. So to get a second on the left-hand side, I have to take this, I have to invert it, and I have to take the square root. So b has to be minus a half. So that gives me, I have a second on the left-hand side. On the right-hand side, I'll have a second divided by a square root of a meter. And to get rid of that square root of a meter, I have c, which I haven't fixed yet. And that tells me that c has to be a half. And that's the only way that this will work out. So dimensional analysis tells us that the period of a pendulum is proportional to the square root of the length over the local acceleration due to gravity. And then, in fact, when we work this out later on in the semester, we will find that we can have an equality that involves 2 pi times the square root of L over G. So dimensional analysis can't fix what this leading constant is, constant of proportionality, if it is dimensionless. And 2 pi is dimensionless. So dimensional analysis can do a lot for you, but it can't do everything all on its own. So a very useful skill. It's very good for catching mistakes that you have made, but it is not the be-all and end-all of physics. So we're not done after the first chapter.